Hello and welcome to another Prof episode. In this episode, we'll be covering some of the work of Dr. Ali Navabi. Ali Navabi was a wheat breeder at the University of Guelph. He also taught grain science at the University of Guelph. In this episode, we'll talk about his wheat breeding work. Let's get started. Dr. Navabi worked extensively on increasing yield within spring wheat, but this often comes at the expense of grain protein. The question of why has been analyzed by several researchers. Dr. Cronstedt suggested that the decrease in protein content was caused by the fact that cultivars that are semi-dwarf have higher harvest indices, and these traits are negatively correlated to grain protein. In essence, breeding for higher yield indices automatically decreases yield because genes that correspond with low protein and genes that correspond to higher yield are connected via linkage, and vice versa for the opposite. Dr. Austin also suggested that it may be due to not gene linkage, but by greater carbohydrate assimilation in the high-yielding varieties, which corresponds to lower protein content. The linkage theory became more prominent, however, in 1990, when Dr. Navabi discovered that in winter wheat, the genes for grain yield and protein yield have no linkage and are segregating in nature, meaning that you can theoretically breed for both, without causing any trouble with either one. The first attempt to increase yield and protein occurred in 1994 by breeding either for longer grain field periods and/or faster grain field periods. This did not increase total yield, but it did increase grain weight, however, which corresponded to increased yield indirectly. The genes for this process seem to be additive and have no linkage with other genes. The late Dr. Navabi's goal at that time was to find the answers to these three questions. 1. What's the genetic variation between grain yield, maturity, protein content, and the earliest maturity within the genetic populations? How are these traits related to each other? Are there any traits or genotypes that do not fall within the boundaries of common relationships between maturity, grain yield, and grain protein? To that end, 130 wheat cultivars were analyzed using both morphological and genetic technology, and here are the results. Based on the experimental crosses and genetic analysis, on average, through selection you can improve anthesis genetics by 3% per generation, 4% for improved maturity and grain fill duration, 6% for spikes per meter squared, 8% for grain fill rate, grains per spike, and grain rate. You can also improve plant height by 13% per generation. There's also a general improvement of 10% per generation in grain yield, and a 5% improvement for grain protein content. This is all the genetic gain you can obtain through one cycle of selection. This was higher than all expected variables with the exception of plant height. And within this situation, although protein and yield increased simultaneously, they both increased by a small amount. As such, careful selection for all traits is possible, albeit more complicated. There were of course exceptions to these rules. These three lines were CIMMYT 250, CIMMYT 259, and CYMMYT 274. These cultivars mature roughly 10 days earlier than the population mean, had 2% higher grain protein content, but between 18 to 44% lower grain yield than the population mean. The Czech cultivar, of which all other cultivars were compared against, was AC Splendor, which had the earliest maturity, highest grain yield, and highest protein content. Dr. Navabi was able to also split wheat cultivars into three different sections. The first group included the free line. Group 2 consisted of a great many cultivars that had average maturity, but 11 to 20% higher grain yield than the population mean. And Group 3, which consisted of 5 cultivars, had a yield roughly identical to the population mean, but had a higher protein content ranging between 0.8 and 2.3%. These were on average also 1 to 6 days earlier in maturing, again in comparison to the population. And that about covers everything. Thank you for watching. Thank you for watching this video. If you enjoyed this video, please like and subscribe. If you really enjoyed it and think you can donate, you can do so at Buy Me a Coffee, link in the description below. Thank you for watching.